Alright, so I think I'm recording. We're ready for your favorite problem, the last problem. Alright, so again, we've been studying in this skill packet. So far we've been looking at relations. First, they gave us relations as a finite set of ordered pairs. We know that a relation is just a set of ordered pairs. But they might present us this relation in different ways. Like I say, as a list, or maybe a graph, or in this case, an equation. So, anytime I'm finding the domain and given an equation, I always start out the exact same way. So, if you haven't written this down by now, since it's been on every single slide, I would suggest that you know this. So the domain is a set of all real numbers, excluding any values that cause division by 0, excluding any values of x that cause us to take an even root, like a square root, of a negative number. Well, I don't have to worry about square roots because I don't see any square roots in this problem. So I don't have to worry about the second part. But I do have a variable and a denominator. I am concerned that 2x squared minus x minus 6 might equal 0. So this is a quadratic equation. I can generally solve this hopefully by factoring. That's usually the quickest method. If I can't solve it by factoring, I know that completing the square or the quadratic formula will always provide me solutions. So you guys learned in Algebra 1 a technique that they call the x method. They draw an x over this middle term, and that creates a space at the top of this x for us to multiply the first term times the last term, and we get negative 12x squared. Then there is a trial and error portion. There's a part that you have to think about, a part that you might have to come over to the side and write scratch numbers. You need to come up with two numbers, and I don't know yet what they are, but when you multiply them, you get negative 12. But at the same time, when you add these two numbers, you get a negative 1, this middle term. Okay? So fortunately, 12 is not that big of a number, and you can play around and recognize that a negative 4 times a positive 3 multiplies together to get us negative 12, and a negative 4 plus 3 adds together to get us a negative 1. So in this x, we put negative 4x and 3x. Okay? Now normally, well, I shouldn't say normally, when the leading coefficient is 1, we just jump right in and use these numbers and factor that. But when the leading coefficient is not 1, it is suggested that you continue in the form of a table. So our tables were nice when we were multiplying. A table is a nice way to be organized when you're using the distributive property. So our diagonal, our first term and our last term, we write those along one diagonal. And the two numbers that we found in the x, here and here, we write those along the other diagonal. Now it doesn't matter where I write the negative 4x. I could write it here, or I could have written it in the upper right corner. Like I say, it just matters that we put those along one diagonal. So now we look and see what the greatest common factor horizontally and vertically for these columns and rows. I see that both of these values are even and they're both negative numbers, so a negative 2 divides both of those values. Up here, I look and see that a 3 divides both of these values, and, excuse me, well, I had to cough, and I didn't want to cough into the microphone. I'm sure you didn't want to. I kind of did, but I hit the pause as fast as I could. Sorry about that. I look horizontally, and 2 and 3 are relatively prime. They don't. Only the number 1 divides both of those, but they both have an x. So we'd say the greatest common factor is x, or if you want to write 1x, that's fine. So now, vertically here, both of these have an x, and they're both even numbers, so we write it as 2x. Well, 1x times 2x is 2x squared. 1x times 3 is 3x. Negative 2 times a positive 2x is negative 4x. And we already said that negative 2 times a positive 3 was negative 6. So this has allowed us to help us to solve this equation. We can factor this and write it as x minus 2 times 2x plus 3. Don't forget that that equals 0. All right, so let's give ourselves some room here. In factored form, it's now easy to solve this equation because we have the zero product theorem. This x minus 2 equals 0, or 2x plus 3 equals 0. So x minus 2 is just a one-step equation. You just add 2 to both sides and you're done. Generally, we don't even write the x minus 2 equals 0. We just look up here and we see that 2 minus 2 gives you 0. Now this guy is a two-step equation. First step, subtract 3, and the next step, divide by 2. That's the coefficient. So we have negative 3 halves. And many of you can skip those two steps and just write it directly as negative 3 over 2. If you can, if you're making sign errors or if you're making silly errors, then go ahead and write it out and show your work and include the steps. So what have we found now? These are the two values that were solutions to this equation. Well, where did that equation came from? That equation came from the denominator. Remember that we were trying to find values of x that would cause division by 0 because we have to avoid them. Positive 2 and negative 3 halves are two numbers that if you plugged them in, you would have a 0 in the denominator. So these values of x would not be related to any y value because when you went to do the arithmetic and you divide by 0, well, that's not a real number. So let's draw a number line. Negative 3 halves is smaller than positive 2. I'm excluding those values from my domain, but those were the only two solutions to this equation, 2x squared minus x minus 6 equals 0. Those are the only two values I have to exclude from my domain. So my domain is all real numbers, excluding these two values. So we can write this in interval notation. It's hard to describe an infinite set of numbers, so they have devised a way, a notation, where we write the smaller value, comma, the larger value. Negative infinity is not an endpoint, so it's not a number. It's an abstract idea. That's why I can never put a bracket around it. This negative 3 halves, or if you want to write negative 1.5, that's fine. That's excluded. That's not in my domain. But the values that are between negative 1.5 and positive 2 are. So from negative 3 halves to 2. And values that are bigger than 2. 2 is excluded. So I need a union. See, I don't have brackets at 2 because I'm excluding it. All the way out to positive infinity. So there's my domain for this. All we did was factor the denominator, which you've done plenty of times in Algebra 1 and Algebra 2 and in this class. I mean, the very first weekly, the very first assignments, problems that I gave you involved factoring. So what you haven't done before is taken those values and draw it on a number line and throw those out and consider all the other points left behind on the number line. And you've never written it in this interval notation until, I don't know, a week ago or so, whenever we started the skill packet. All right. Now we're interested, that's the set of x values, and we want to find what these x values are related to. They're related to y values through this equation. So by looking at the graph, it will help us to describe all these y values that we call the range. So I have went ahead and keyed this in to this graphing calculator. Well, no, I haven't. The reason I didn't key it in, when you have a numerator like this, you want to put that numerator in parentheses. Otherwise, it'll just have be 2 divided by that. And we want the whole thing 5x minus 2. So I need parentheses. And then now, sometimes I don't put parentheses around this denominator when I'm keying it in, but on like calculators, you always need to. So it's probably smart for us to put parentheses around both the numerator and the denominator. So let's do that. So as soon as I hit the parenthesis, it closes it for me, and I have 5x minus 2. 5x minus 2. Then I go to the outside, I have to hit that right arrow key to get to the right of that parenthesis, and I hit divided by. And now I key in this denominator, which is 2x squared. So I have 2x, and I can just hit the square button right there, and it knows to square it. Because we use that square so often, there's a button for it. Then minus x minus x. Minus x. Oh, and I said I was going to put parentheses around this, didn't I? So let's go back. And then minus x minus 6. Definitely maybe a little bit more important when you're plugging in numbers on a calculator, that denominator. So anyway, I've got parentheses, or I've clearly told this graph, there's my numerator, there's my denominator, do that division. All right, so let's take a look at what we have here. Well, let's get a picture of it. We saw a similar situation in one of the other problems, that we've got kind of a complicated graph here, but I can focus my attention on the middle part of this graph because I can easily see it's going up to positive infinity, it's going down to negative infinity, and that I don't have any holes or any jumps in the graph all the way. All of these y values are repeated over here, these positive y values, but once you're in the set, you're in, and all of these values are repeated over here. And although this part of the graph is never touching the x-axis, this part of the graph never will have a y value equal to 0, it's passing through the origin. So I know that the domain is a set of all real numbers. We've seen this type of graph before, so hopefully you can make that connection. Once you've seen it one time and now you've seen it twice, hopefully it'll become easier each time you see a graph like this, that you can identify that the range is a set of all real numbers. So that's the last problem there, and I hope that helps, and I will talk to you later.